Welcome to PERL tutorial. In this tutorial, we are going to learn about PERL Basics with some simple example scripts. But please do note, this is only for absolute beginners. If you are an advanced user of PERL, you may want to skip this. Okay, let's get into it. Here is the list of topics that I am going to walk you through in this tutorial. We develop PERL programs to manipulate some kinds of data. The data can be either an integer number, a floating point number, a string, or more complex such as a list. Data is held as value. To hold a piece of data, we need variables. For example, here to store the integer of 5 into a variable called a, so we can do like this. So here, as you can notice, the variable name is prefixed with a $sign. And similarly, we can assign the floating point number and the strings as well. In PERL, an expression is anything that returns a value. For example, here 5 is an expression that returns a value of 5. And in the second statement, $x plus $y is an expression that returns the sum of these two variables. Okay, so basically a statement is made up of expressions and a statement is executed by PERL at runtime. Okay, do note that in PERL each statement must end with a semicolon sign. Next we have blocks. A block is made up of statements wrapped in curly braces. We use blocks to organize statements in the programs. So any variable declared inside a block has its own scope. Meaning the variables declared inside a block only last as long as the block is executed. We'll see more on this later in the tutorial. Okay, comments in PERL. So we can write comments in two ways. So basically in PERL, a comment begins with a hash character. So we can write a comment in a new line starting with a hash character, or we can write a comment inline as well. So as you can see here, so the comment is starting after the end of semicolon symbol. So comments are very important and useful to us as a programmer in order to understand the code later. They are also useful to other programmers who will read and maintain our programs in the future. Okay, white spaces in PERL. So white spaces are basically spaces, tabs, and new lines. PERL is very flexible in terms of white space usages. So here both statements works perfectly fine. In the first statement, we surrounded the assignment operator equal with white space, okay, but not in the second one. PERL really doesn't care about the white space. However, it is good practice to use white space to make the code more readable. And finally, we have keywords in PERL. So basically, keywords have special meanings to its language. Okay, so we should always avoid using keywords to name variables, functions, modules, and other objects, for example. Because sometimes it is fine to use a variable name such as $print, which is quite similar to the built-in function print. However, this may lead to confusion. In addition, if the program has an issue, it's more difficult to troubleshoot. Let's write our first program in PERL. To know where PERL is installed, just type which PERL. So here the first pair of characters, hash and then followed by exclamation, tells the shell to execute the script with the PERL interpreter. In this case, this file is transferred to the PERL interpreter that resides in this folder. And now I am writing a pragma, which is the use warnings. So this pragma instructs PERL to turn on additional warning reporting. Later on in this tutorial, we will see another pragma such as use stricts, which is highly recommended to use. And then I am using the built-in function print to output a string. So here do note that the string must be enclosed inside the quotes. Okay, we will see more on that in the strings lesson later on. And \n at the end of the string is the escape sequence, which is the new line. Alright, let's save this file and execute. PERL space and then the program name. Here you go, output on the screen. Variables in PERL. We use variables to manipulate data in our programs. PERL provides three types of variables: scalars, lists, and hashes. We'll focus on scalar variable in this lesson. We use scalar variables to manipulate scalar data such as numbers and strings. A scalar variable in PERL starts with a $sign followed by a letter or underscore, and after that any combination of letters, numbers, and underscores. Let us run this program and see. So as we can see here, we are able to print the values of both these two variables. They both are valid. Do note that if you use a variable with $sign inside the double quotes, PERL will interpolate that. So it will basically replace the string $test with its value. So we'll talk more about this in a minute. Now let us look at some of the variable names which are invalid in PERL. So for example, this particular variable name is not starting with a letter or underscore after the $sign, so which is invalid. And PERL flags an error on this. And if you look at this message, it clearly says that there is a syntax error at line number 15. So that way it is easier to debug. And the second variable name here contains a special character of hyphen, which is also invalid in PERL. And PERL flags an error. And the third variable here contains a space, which is also invalid and does not accept by PERL. So in these three cases, PERL flags an error. And PERL is case sensitive, meaning $lowercase a and capital A are two different variables. They can hold different data. We can verify this by running this program again. So as expected, lowercase a is holding a value of 1 and uppercase a is holding a value of 2 here. Now let us see how to declare variables in PERL. PERL doesn't require us to declare a variable before using it. For example, we can introduce a variable in our program and use it right away. So as we can see here, we declared a variable called x and at the same time we assigned a value of 5. And the same way we assigned a value of 6 to y. And we are trying to print the value of z here, which is the sum of x and y, which is 11. Now let us see another example with variable declaration. So in this example, we assigned a value of green to color, and inside this print statement, we are printing a different variable here, which is not declared before using it. So now if you run this program, it will not error out. That's because, as we saw just now, PERL doesn't require us to declare a variable before using it. So rather, this particular variable is now printed as an empty string here. This could be a typo. You might have wanted Perl to warn you. So if you want that to happen, we'll have to use a pragma called strict. So when you use that strict pragma, basically it requires us to declare variable explicitly before using it. Now let us try that. Let us add the pragma strict here and run this program again. So as expected, Perl is now warning on both these variables. Now let us look at the variable scopes in Perl. So here we have declared a variable called fruit, and we are trying to print that particular variable at 3 different locations. So in the first print statement, we got the mango, and inside this block, we got a different value of apple, and when it came out of the loop, so again we got the value of mango here. So basically what happened here is, first we declared a global variable named fruit, then we displayed the favorite fruit by referring to this $fruit. As expected, it returned the value of mango. And next, we created another block here and with a variable of the same name again using my keyword here. So now $fruit variable is lexical here. It means it's a local variable here and only visible inside the enclosing block, this particular block. And after that, inside this block, we printed the $fruit again, so which will be replaced with a value of apple here because of my keyword, so it got the local scope here. So it doesn't print mango, so it only prints the value which is local to this block. And finally, following this block, we refer to the $fruit again, and Perl referred to this particular thing as a global variable. So the value of mango is printed back again. But if you want to declare global variables that are visible throughout your program or from external packages, you can use our keyword just like this. So that this particular variable will be seen throughout the program. So yeah. Now let us see variable interpolation in Perl. Perl interpolates variables in double quoted strings. It means if you place a variable inside a double quoted string, you will get the value of the variable instead of its name. So as expected, $val is substituted with its value 10. So basically Perl is interpolating the value of $val into the string which is 10 here. Note that Perl only interpolates scalar variables and arrays, but not hashes. We'll see that later. In addition, the interpolation is only applied to the double quoted string, but not the single quoted string. Let's say if you had a single quote here instead of double quote, the string which is enclosed in the single quote will be printed literally here. And you also get this message that's due to the pragma warnings here. So this will tell you something is wrong in your code, which you might not have wanted. So basically this particular message is saying that main val is only used once, possible typo, so at interpolation, and it gives the line number as well. Now now let's say if you have commented this out, so you will not get that message. So you will only get the output from this print statement. Let me undo this. And now let's use the pragma strict again here to see what happens. So this will now flags a warning. So that's because when you use strict, it expects U to define the scope of a variable at the time of declaration. Let's say we can define it as my or our. So in this case, let me define it as my. So this way you can correct your variable declaration scopes. So it's always better to use the strict, to know if your variables are declared as expected. Yeah, that's about the variable interpolation in PERL. Numbers in PERL. Like in other languages, PERL also supports both integer and floating point numbers. We take a look at integer numbers first. Integers are whole numbers that have no digits after the decimal points. For example, here we have both positive and negative integers. In PERL, integers are often expressed as decimal integers, meaning with a base of 10. Okay, so this is interesting here. Let's say if you are dealing with a bigger number, something like this, so you often use comma as a separator to make it easier to read, write, something like this. PERL has a way to do this kind of stuff, but not with the comma operator, because comma is used as a separator in the list. So for integers, PERL uses underscore character instead. Let's say if you want to assign this big number into a variable, so you can split this with a underscore and you can have it assigned. And during the print, PERL interpolates this as a single number. Let us verify this. So as expected, PERL prints this as a single number. If you notice this, we didn't give a split operator here. Okay, besides the decimal format, PERL also supports other formats including binary, octal and hexadecimal. We'll take a look at that using a simple example here. So in PERL, binary integers starts with a prefix of 0b, octal integers using a prefix of 0, and hexadecimal integers using a prefix of 0 small x. If you notice here, we have an inline comment. This is explaining how this number is being translated into an integer. Now let us print these three variables and see what we get. So basically all these three numbers are getting translated into an integer of 14. I want to touch on format printing here. The concept is pretty much similar like in other languages and the syntax as well, to make this output much more readable. So format printing can be done by using the function called printf. So this is basically reserves a fixed width, and depending on how you want output to be printed, either from left to right or from right to left, you can use the left and right justifications accordingly. So if you notice here, for strings I have a fixed width of 12, so it fixes a space of 12 characters and starts printing from the left to right. And for the integers, I have a fixed width of 5 character space and I am printing using the right justification. So this is basically prints from right to left. Let us run this program again and see what happens here. So now the output is much more readable. Okay, this is about the integers in PERL. Now let us look at the floating point numbers. We use floating point numbers to store real numbers. PERL represents floating point numbers in two forms: fixed point and scientific. Fixed point, decimal point is fixed in the number to denote the fractional part. And in scientific, it consists of a significand with the actual number value, and an exponent represents the power of 10 that the significand is multiplied by. For example, this particular floating point number in fixed point can be mapped to this particular number in a scientific form. So both are essentially same. And also notice that you can use either small e or capital E for the scientific forms. So both will work just fine. Okay, so in PERL, floating point number holds 8 bytes with 11 bits reserved for exponent and 53 bits for the significand. In this lesson, we are going to learn about operators in PERL. So PERL operators include numeric, string, and logical operators. Let's take a look at numeric operators first. PERL is providing numeric operators to help us operate on numbers, including arithmetic, boolean, and bitwise operations. Let's take a look at arithmetic operators first. PERL arithmetic operators deal with basic math such as addition, subtraction, multiplication, and then division. So these are quite straightforward. Okay. But when you combine all these operations together, PERL will perform the calculation in an order, which is known as operator precedence. Okay. Meaning the multiply and divide operators have higher precedence than add and subtract operators. So look at this example here. So here both division and multiplication happens first and then finally the addition. So which returns the output of minus 25 here. And let's say if you want to override this default behavior, you can group the things. Okay, so you can use parentheses to force PERL to perform calculation based on the precedence that you want. So here I want the addition to happen first, so I group them in the parentheses. So this returns a value of 60. So you can see how the calculation is done in this inline comment here. And we have an exponentiation operator, which is the star star. So basically to raise one number to the power of another number, we can use this operator. So 2 to the power of 4, which is 16 here. And then we have a modulo operator, which is the percentage sign. So it is quite handy to use this operator to check if a number is odd or even by dividing it by 2 to get the remainder. Especially is used with if conditions. Okay, so that's about the arithmetic operators. Now let's look at bitwise operators in PERL. So bitwise operators allow us to operate on numbers 1 bit at a time. Think a number as a series of bits that can be, for example, here 7 can be represented as 0, 1, 1, 1. Okay. PERL provides all basic bitwise operators, including AND, okay, and then we have OR, and then we have exclusive OR, then we have NOT, which is the tilde, and then we have shift right, and we also have shift left. Let me run this program and show you the output. So here first the AND operation, so $A and $B, which is 1 1 here bitwise operation 1, and then 1 1 1, and then 1 0 is 0, and then 0 0 is 0. So basically the truth table of the AND operation here. And the same way we can perform OR, exclusive OR, and the NOT operation. So for NOT we are seeing a huge number here. That's because I'm running on a 64-bit computer. And the way shift right works is it shifts the bit to the right, and then after shifting out, so it fills the leftmost bit with 0. So in this case 0 1 1. So this is equivalent to 3 in decimal. And when it shifts left, then the rightmost bit will be filled with 0. So in this case 1110 is equivalent to 14 in decimal. Okay, so that's how bitwise operators work in Perl. And now let us see the comparison operators for numbers. So I have two variables here, a and b. And these are the comparison operators we have in Perl. Equal, equal to check the equality. Not equal to check the non-equality. And then less than, greater than, less than or equal, and greater than or equal. So this is quite straightforward again. Nothing much to explain here. And here is the interesting thing in Perl. So we have this operator called spaceship operator. Oops. Okay, so the spaceship operator, which is basically this less than, equal, and then the greater than combined together. So this is how it works. So it returns 1 whenever $A is greater than B, and returns 0 when both are equal, and returns -1 when $A is less than $B. So I print these values by varying the value of B here. Okay, so that's about the spaceship operator. Now let's move on to string operators in Perl. So in this example, I have two strings, string 1 and string 2. They both have different values. And these are the operators we have. So just like we saw for numeric operators, we have these 7 operators for strings. So EQ for checking the equality, NE for non-equality, CMP for comparing, LT less than, GT greater than, LE less than, and less than or equal to, and G for greater than or equal to. Okay, so the other things are quite straightforward. Let me talk about the CMP here. So the way CMP works is it returns -1 whenever string 1 is less than string 2, and returns 0 when both are equal, and it returns 1 when string 1 is greater than string 2. So if I run this program here, so we get this output. So here we are getting this particular statement from the print, right? So that's because here string 1, which is 1, is less than string 2, which is 2. So which makes the condition true. That's because it returns a value of -1, which is still a non-zero value. So that makes this particular expression true. So we get this output. Okay. So, and the other outputs are pretty straightforward. So whenever string 1 is greater than string 2, string wise, so it returns that particular thing, and whenever it is less than string 2, then it returns this particular output here. Okay, and next we have is the concatenation operation, so which is basically the dot operator. So this is used to combine things. So as you can see here, both strings are now joined together using the dot operator. And then we have the repetition operator, which is the x, small x, and then followed by the number of times that you want to repeat the string. So in this particular example, I am repeating this text 4 times. Okay, so that's about the repetition operator. Now let us see a bit about a chomp operator in Perl. Okay, so basically the chomp operator removes the last character in a string and returns a number of characters that was removed. So here a chomp operator is very useful when dealing with user's input, because it helps you remove the new line character from the string that the user entered. So here we get the input from the user using stdin function, and then we remove the new line character using chomp, and then we are printing that string. So let's run this program here. So it expects a input from the user. Let me type in something and press enter. So as you notice here, the Unix prompt is returned on the same line as the output, and there is no character between the output and the Unix prompt. That's because the chomp has removed the new line character here. Okay, so that's about the chomp operator. And finally, let's talk about the logical operators in PERL. So here again, I have two variables A and B. So logical operators are often used in control statements such as if, while, given. So we'll see that later. So these are the logical operators that are supported in PERL. So and for performing the logical AND operation, and or symbol for or, and then not exclamatory for performing the not operation. I guess most of us are familiar with the Boolean truth tables. So let me just run this and show you here. So this in this particular example here, both expressions are evaluated to true. That makes this whole expression evaluates to true. So we get this output. And again, so both are true here. That makes logical OR to true. So we get again this output. And here $A is the non-zero value. So, and again, not of the non-zero value makes the evaluation to false. So that's why we don't get this output here. Strings in PERL. A string is a sequence of characters surrounded by some kinds of quotation marks. A string can contain ASCII, Unicode, and escape sequence characters such as new line. A PERL string has the length that depends on the amount of memory in our system, which is theoretically unlimited. Now let's take a look at strings with some examples. So here I have a variable called $var, and I'm going to use this inside double quotes and single quotes, and let us see what we get from the print statement. Okay, so here do note the double quoted string replaces variables inside it by their values. Okay, so this is what the interpolation is about. So inside double quotes, $var is now substituted with its value. However, single quoted string treats it as the normal text. Okay, so the literal dollar and then followed by var is printed here. Okay, so that's the difference between using a variable inside double quotes and single quotes. Besides single and double quotes, PERL also allows us to use quote-like operators. For example, Q followed by string within the delimiters, so is equivalent to as if you have your string inside the single quote, and QQ for the double quotes. Okay, so let's try this out with an example. So again, I have a variable called $name which has this value, and I'm going to use that inside single and double quotes, and let us just print this and see what we get. So okay, so this is behaving as a string in single quote. So $name is now treated as the normal text. However, inside QQ operator, it has been interpolated. And you can also notice a color difference when it is inside and when it is inside the single quote and when it is inside the double quote. You can see a color difference. So yeah, so this way you can figure out whether you have your variable name has got some special meaning or not. In fact, you can find the same thing here as well. So you can see a color difference between single and double quotes of a $var. Okay. And do note, we can choose any non-alphabetic and non-numeric character as the delimiter for the Q and QQ operators. So in the previous example, we have used / as the delimiter. So now I'm going to use various delimiters, okay, to print the same string. So as expected, all these statements are returning the same output. So basically, you can use any special character as the delimiter. So the only thing to note is it should be a non-alphabetic and non-numeric character. Okay. Okay, so that's about the Q and QQ operators. Now let us move on to functions with strings in PERL. So PERL is providing a set of functions that allow us to manipulate strings effectively. So let's take a look at most of the commonly used ones here. So let's say if I want to know the length of my string, I can use the function called length, which returns the number of characters in the string. And to convert your string into the uppercase, we use UC. And similarly, to convert into a lowercase, we use LC function. Okay. So that's about the changing cases. Now let us see the use of index function with strings. So basically, the index function searches for a substring inside a string from a specified position and returns the position of the first occurrence of the substring inside the searched string. If the position is omitted, it searches from the beginning of the string. So in this particular example here, I have my substring which is assigned to $sub and $s is my main string. And I am trying to find out the index of this particular substring in my main string. Okay, so it says uppercase PERL is found at position 9, which is basically index 9. We also have a reverse function available in PERL, which can be applied on strings as well. So as you can see here, we are trying to print the scalar value of this function here. So as you can see, the string is now reversed. And we can also apply the reverse function on arrays as well. So we will see more on arrays later in the tutorial, but for now let us just look at this example just to see how reverse works on array elements. So as expected, the elements from right to left are now being printed on the screen, not from left to right. Okay, so that's about the reverse function. And finally, we have a function called substring, which we can apply on strings as well. Let's say if you want to extract a particular portion out of the string, so you can use the substring function. So in this particular example, I'm trying to extract a sub portion which is starting from index 4. So if you see this string over here, the fourth index is basically a space, and after that it prints all the way to the end of this string. And we can also work with a negative index. So as shown here, I am trying to extract the string from the -9th index. So this is how it works. So basically the rightmost character starts at 0th index, and then the next one to it on the left, which is the -1 and then -2 and so on. So in this particular case, -n happens to be the character B, and that's where it ends, and it extracts that particular word. And we can also extract a substring which is of a fixed length. So here I have my range defined, so 0 to 4. So basically I'm trying to extract the substring which is starting from index 0 and ending at index 4. So which is basically the first word, including the space here. And finally, we can replace the substring with a value also. So for example, in this here, I am trying to replace the substring which is starting at index 9 and ending at index 17. So that particular substring I am going to replace with the string I have put in this double quotes here. So in this particular example, the word that matches for index 9 to index 17 is the last word. So that is now being replaced with the value that we have put here. In this lesson, we are going to learn about lists in PERL, and we also look at how to manipulate list elements using various techniques such as list slicing, ranging, things like that. A PERL list is a sequence of scalar values. We can use parentheses and comma operators to construct a list. And each value in the list is called a list element. List elements are indexed and ordered. We can refer to each element by its position. Now let us take a look at them with some simple examples here. So the first one, we have an empty list here using the empty parentheses. And over here we have a list of integers. And in the third example, we have a list of strings. So if you remember, we used the print operator many times to display a number or a string in previous lessons. So basically the print operator is a list operator. So let us display our lists using this print operator here. So as you can see here, the first list returned an empty string, and the second list is returning a list of integers, and the third one is returning a list of strings. And if you notice here, all these lists are separated using a comma operator. And whatever the lists that we have seen here are containing an element with the same data type. So these lists are simple lists. Now let us take a look at complex lists using a simple example. So I have a variable called a, which is holding the integer 10, and I also have another variable which is holding a string, and I'm trying to put them into a single list here. So as you can see here, now this list is returning both string and the integer. Okay, so this is about the simple and complex lists, and we have QW function in PERL. So basically this function allows us to get a list by extracting words out of a string using the space as a delimiter. So basically QW stands for quote word. Let us see this with a simple example. So first I'm trying to print a list over here, and I'm trying to show you the usage of QW function here. So the same string I have assigned using the QW function. So basically quote word, and inside the parentheses I have put the same string. And let us print this and see. So as you can see here, we got the same output. And as we saw in the previous lesson, like Q and QQ, so we can use any delimiter for QW as well. Meaning it needs to be a non-alphanumeric character one. So I have some simple examples for that. So here I'm trying to use various delimiters, for example, backslash, the flower brace and the square brace. They all return the same output. So basically you can use a delimiter which should be a non-alphanumeric character. Okay, that's about the QW function in PERL. And now let's talk about the flattening list in PERL. So if you put a list called internal list inside another list, PERL automatically flattens the internal list. So I have an example for that here. So here if you see I have two lists combined together here. So 5, 6, 7 and then 8, 9 is another list, and which is combined here. So which returns the value of all the elements together. And the same way, if you have a list something like this and also like this, so all the combinations here returns the same output. So basically PERL does the flattening. Now let us look at how to access list element in PERL. So we can access elements of a list by using the 0-based index, meaning to access the nth element we need to put n-1 index inside the square brackets. That's because the index starts from 0, not from 1. Yeah, please note that. So in this example here, I'm trying to access the first element, which is starting at index 0. So which is basically 1 here. And in the second example, I am trying to access the element which is at the 4th index. So which is basically the last element here. And we can actually access multiple elements of a list as well at the same time. So for that, we can put a list inside square brackets. This feature is called list slicing. So here I am trying to access the values which are placed at index 0, 1 and 2. Okay, so this way you can get multiple elements from a list. So apart from this, we have another concept called ranges. So in PERL, we can build a list based on a range of numbers or characters. For example, to get a list of numbers from 1 to 50, for example, so we can use an operator called ... So which basically expands the list from 1 to number 50. So okay, so yeah. And the same way we can print alphabets starting from A to Z using A ... Z. Arrays in PERL. Okay, before we look into arrays, let us understand the difference between the list and an array in PERL. So a list is immutable, so you cannot change it directly. In order to change a list, you need to store it in an array variable. By definition, an array is a variable that provides dynamic storage for a list. So in PERL, a list is immutable, whereas an array is mutable, meaning you can modify the array elements, grow or shrink the array, but not a list. Okay, and note that in PERL, a scalar variable begins with $sign. So we have seen that in the previous lessons. However, an array variable begins with @sign. Now let us see with simple examples here. Now let us declare an array variable first. So here I have an array called fruits, and if you notice here we have prefixed with @sign, which indicates this is an array, and we are assigning some words to this. And for printing, we can just use @sign followed by the array name. So this returns the elements of all this array. And this is how we declare an array variable. And now let us see how to access array elements in PERL. Let us declare an array again here. And to access PERL array elements, we have to use square brackets and indices. So as shown here. So here I'm trying to access the first element, which is at index 0. Do note that array elements starts with the index of 0, not 1. So this returns the first element of the array. And we can also access multiple elements from an array as well. So for that, we can use an operator called ... So we have seen earlier. So here I'm trying to access elements from index 1 to index 3. And now let us print that and see what we get here. So as expected, it returns the values at index 1, index 2 and index 3. And we can also access in the other way as well. So we can pass negative index and to access array elements as well. Now let us see how this works here. So if you see here, I'm trying to access values from index -2 to +1. So basically in Perl, the array, when you access with a negative index, so it starts from the right. So the rightmost index would be a -1, and then it goes left with the index of -2 and so on. So here if you see, this is -1 and this is -2. So we are accessing from -2, which is this one, and then -1 is this one, and then it goes to 0, which is apple, and the value at index 1 is this particular element. Yeah. And now let us see how to count the array elements. So if you treat an array as a scalar, you will get the number of elements in the array. So here I'm trying to assign the array to a scalar and trying to get the number of elements in this particular array, which returns 5. However, this particular piece of code might cause an error in case you don't really want to count it but accidentally assign an array to a scalar. So to be safe, always use a scalar function explicitly to get the scalar value. So for example, we can rewrite this using this way. So here I am assigning this scalar value using the function scalar. So this will return us the number of elements in this array. And this is the safest way. And to get the highest index of an array, we can use this operator, basically dollar and then followed by hash and then the array name. This gives the highest index of this particular array, so which is 4 in this case. So basically the number of elements is, if the number of elements is n, then the highest index would be n-1. Okay, so this is how we count the elements in an array. Now let us see how to modify array elements. To change the value of an element, we access the element using the index and assign it with new value. So Perl allows us to change values of multiple elements at a time as well. So let us declare an array here. So I'm trying to force the first element to this value here, okay, and then I'm trying to add multiple elements as well. So again, using this continuity operator dot dot. So I'm trying to put these values at index 1 to 3 and printing this array here. So now if you see, this particular string is now placed at index 0, and then the values which were at index 1 to 3 now got replaced by the values that we put here, and the final one didn't affect here. So this way we can modify the elements in an array. Okay, now let us see array operations in Perl. So Perl provides several useful functions and operators to help us manipulate arrays effectively. We'll cover some of the important concepts here. So we'll see Perl array as a stack with push and pop functions. So both functions, push and pop, treat an array as a stack. So basically a stack works based on last in first out philosophy. So here push function appends one or more elements to the end of the array, while the pop function removes the last element from the end of the array. So let us understand this with an example here. So I'm defining a empty array here, which is a stack, and I'm trying to push the value of 1 to the array, and I'm printing the same to confirm that. So, and again I'm trying to push 2 more values to this array stack. And now if I print, so we have these 3 values, and let me print the whole array again here. So which returns the values of 1, 2, 3, which we have just pushed into this array. And now I'm trying to fetch the values from this stack here. So for that I'm using pop function. So pop and then at stack. So basically this removes the last element from the end of the array, which is 3. And if I pop the array again, so it should return just before the last one. And yeah, if you access it again, then it should return the value that is at the index 0, so which is in this case the value 1. Okay, so this is how the stack mechanism works. Now let us see PERL array as a queue with unshift and pop functions. So if the push and pop treat an array as a stack, the unshift and pop functions treat an array as a queue. So basically a queue works based on the first in and first out philosophy. So here the unshift function adds 1 or more elements to the front of the array, while the pop function we have seen earlier removes the last element of the array. And let us go through this example to understand this. So I'm defining an array here called Q and assigning it with an empty string here. So now I unshift the value of 1 from this array called Q. So I'm doing this operation a couple of times again. So I'm printing also what I'm trying to unshift from this array. And now if I print this particular array called Q, it returns the value that we have just unshifted. And now let's say if I pop this array, so what it does is again let me define a variable class for this, otherwise the strict pragma flags an error here. So here when I pop this particular array, it basically removes the element, basically removes the last element of the array, which is 1. And the same way I can perform this operation until I get the first element. Okay, so this is how it works. This is the PERL array as a queue. Now let us see how to sort arrays in PERL. So PERL provides the sort function that allows us to sort an array in alphabetical or numerical order. So here we have a couple of examples. So here I am declaring an array called countries and has these values, and I am using the sort function on this array to sort these elements, and I am printing that particular array. So as we can see here, now all the elements are sorted in alphabetical order. Okay. So this is an example of sorting an array of strings alphabetically. Now let us see how to sort numerically. So again I am declaring an array at A with some values here, and I'm trying to show you this is in unsorted order now, and the way we are going to arrange this in a numerical order works in this way. So here we have an unsorted array first. Here we have printed that, and now we use the sort function to sort the at A array. So we passed a block of code, which is this one, to the sort function and applying on array A. So this is how it works. $A and $B are here global variables defined by the sort function for sorting. This particular operator, spaceship operator, we have seen in the previous lesson. So it basically used to compare two numbers. So this particular block returns -1 if $A is less than $B, and then returns 0 if both are equal, and returns 1 if $A is greater than B. Okay, now let us print this and see what we get. So now we have a array which is sorted numerically here. So basically the sort function accepts a block of code that allows us to change the sort algorithm. So okay, so for this particular example, to sort the array elements numerically, so we have changed the default sorting algorithm. In this lesson, we'll learn about another compound data type called PERL hash and how to manipulate hash elements effectively. A PERL hash is defined by key value pairs, and PERL stores elements of a hash in such an optimal way that we can look up its values based on keys. So with the array, we use indices to access its elements. However, we must use descriptive keys to access hash element. A hash is sometimes referred to as an associative array also. So like a scalar or an array variable, a hash variable has its own prefix. So a hash variable in Perl starts with a %sign. So this looks like a key value pair. So remember this trick to name the hash variables. And this is how we define a simple hash in Perl. So here I have some keys and associated values, and I'm assigning this whole set using the QW function to a hash called fruits here. To make the code easier to read, Perl provides the operator which is equals and then followed by a greater than symbol as an alternative to a comma. This helps differentiate between keys and values and makes the code more elegant. So when we see this particular operator, we know that we are dealing with a hash, not a list or an array. Okay, so Perl requires the keys of a hash to be strings. Okay, meanwhile, the values can be any scalars. If you use non-string values as the keys, you may get an unexpected result. In addition, a hash key must be unique. If you try to add a new key value pair with a key that already exists, the value of the existing key will be overwritten. Okay, and also note that we can omit the quotation in the keys of the hash. So we don't have to enclose the keys of a hash in quotes. Okay, now let's perform some basic operations on the hash here. So I'm defining a hash called colors, which has some fruits as its keys, and the colors of their associated fruits as values here. And let us see how we can access the value of a key of a hash here. So here, if you notice, we are using curly braces here. So we use a hash key inside curly braces to look up a hash value. So this returns the value of this particular key from this hash. and we can add a new element by a new key value pair. So this is how we add a new element into this particular hash. So if you see here, we are assigning a value to this new key here. Good. So now our hash is grown by 1 here. And we can also delete a key value pair. So if you know the hash key, so we can remove a single key value pair from the hash by using this delete function. Delete and then followed by the key of a hash. And we can add a new key value pair. So we saw here, so the same way I'm doing it here on another key. And if you want to modify this particular new key here, so you can override that with the value that you want here. So as we mentioned earlier, this will be overwriting the existing key. So in this case, the value of this particular key is now overwritten with this value. Okay, so this is how we can perform the basic operations of addition, deletion, and modifying some stuff inside the hash. And now let us see how to print hash elements. So here I am defining a hash called colors with some key value pairs, and I'm trying to use a for loop and along with a combination of keys function to print the values of this particular hash. So here PERL provides the keys function that allows us to get a list of keys in scalars, and we can use keys function basically in a for loop to iterate the hash elements. Okay, so here keys function returns a list of hash keys, and this for loop visits each key and assigns it to a special variable called $_, and inside this loop we access the value of a hash element via its key as $ and then the hash name followed by the $_ inside the curly braces. Okay, so this returns the values of this particular hash. We'll take a look at the for syntax later in this tutorial. Now let us look at the if statement in PERL. If statement allows us to control the execution of our code based on conditions. The simplest form of the if statement is this: if followed by the expression within the parentheses. And in this form, we can put the if statement after another statement. For example, here I have this if statement which is placed right after this print statement. So here the message is only displayed when the expression is evaluates to true. Okay, so in this case $A is 1. So this particular print statement is being executed here. So there are some rules which are applied when PERL evaluates an expression, and that way it decides if the expression is true or false. So when both number 0 and string 0 are false, undefined value is false, and the empty list is false, and also the empty string. And in all other cases, it will be true. Okay, so the limitation of the PERL if statement is that it allows us to execute a single statement only. So if you want to execute multiple statements based on a condition, you will have to use this syntax. So inside the if block, you can have multiple statements. and have them enclosed in the curly braces. So do note that here curly braces are required even if you have a single statement to execute. Okay, so now let us see this with a simple example here. And so in this example, since a is 1, so this particular expression evaluates to true, and the code inside this if block gets executed. Now let us see if-else statement. So in some cases, you want to also execute another code block if the expression doesn't evaluate to true. PERL provides the if-else statement that allows us to execute code block if the expression evaluates to true. Otherwise, the code block inside the else branch will execute. So the syntax of if-else statement in PERL is this. So if expression, and then you have some code over here, and in the else branch you can also have some code. So let me show you this with a simple example here. I have two variables a and b which are having two different values. So in this case, this particular expression evaluates to false. So that makes PERL interpreter comes here. So the code inside this else branch will get executed. So this is about the if-else statement. And we also have if-else statement in PERL. So PERL provides this kind of statement for checking multiple conditions and executing the corresponding code block. So the syntax of if-else is this. So if expression and then some code inside this, and then else if some expression, and again some code here, and so on, and finally we will have this else branch here. So again an example here. So here both a and b are holding two different values, and since a is greater than b, so it comes over here, and then this particular expression evaluates to true. So this print statement is being executed here. So this is the this is about the if-else in PERL. Now let us look at the unless statement in PERL, which is just opposite to if statement. So basically the unless statement executes a code block when a condition is false. So note that PERL unless statement is equivalent to the if not statement. So the syntax of unless is unless and then followed by this expression within the parenthesis. So this is the simple form of unless statement. So here PERL executes the statement from right to left. If the condition is false, PERL executes the statement that precedes the unless statement. If the condition is true, then PERL skips the statement. So for example, if I replace this if with unless here, so we don't get any output here. That's because this particular expression evaluates to true. And let's say if I change this value to 0, then this particular expression evaluates to false, which makes this print being executed here. Okay, so that's how the unless works in PERL. So again, like we saw in if statement, if you have more than one statement to execute, so we'll have to use this kind of form. So instead of if, it will be unless. So again, the syntax is pretty much similar here. So you can have multiple statements within this curly braces. Okay, so like if else, we also have unless else statement in Perl. So the syntax of that is again pretty much similar to if, but it works just the opposite to if else. So unless expression, and then you have some code over here, and when this particular expression evaluates to true, then it comes to the else branch and the code inside this will get executed. Okay, so this is about the unless else statement. Let us see this with a simple example here. Let me change if to unless, and now run this program again. So here both A and B are holding two different values, and this particular expression here evaluates to false. So that makes this particular print statement gets executed here. So yeah, it works just the opposite to if. And finally, we have this nested thing with unless as well. So Perl supports unless else if else statement. So if you have more than one condition to check with the unless statement, we can use this syntax. Just replace if with unless. Yeah. Yeah, this is about the if and unless statements in Perl. Loops in Perl. Let us take a look at for loop statement first. The Perl for loop statement allows us to loop over elements of a list. In each iteration, we can process each element of the list separately. This is why the for loop statement is also sometimes referred to as for each loop. Now let us look at the for loop syntax with a simple example here. So here I am defining an array with 10 integers, and then using the for loop to loop over elements of this particular array, and inside this for loop I am printing all the elements of the array using the $_ default variable. So we'll talk about that default variable in a minute. So yeah, this returns the elements of this particular array. And now let's say if you replace the for keyword in this example by for each keyword, it works basically the same way. Let us test that out. So I'm just replacing the for keyword with for each and see what happens here. Yeah, we get the same output. Okay, so now let's talk about the for loop iterator. So if you don't supply an explicit iterator to the loop, Perl will use a special variable called the default variable with the name $_ as the iterator. So in each iteration, Perl assigns each element of the array to the default variable $_. So in this case, we are trying to use the explicit loop iterator, so which is the $I here. So $I is the iterator of the for loop in this particular example. So in each iteration, Perl assigns the corresponding element of the array to the $I iterator. Note that the $I variable exists only during the execution of the loop. So if you run this program, we get the same output as earlier. So if you declare an iterator before entering the loop, Perl will restore its original value after the loop is terminated. Let us look at this example here. Okay, so this is how it works. So first we declared a variable called $I before the loop with some value here 20, and next we used a variable $I as the iterator here for the for loop. So its value changes in each iteration of the loop, and finally we are printing the iterator value just to see if it is restored to its original value. So if you see here, the iterator has been restored to its original value after this for loop ends. Okay. Now let us see PERL for loop iterator, value or alias. So in each iteration of the loop, PERL creates an alias instead of a value. So in other words, if you make any changes to the iterator, the changes also reflect in the elements of the array. Take a look at this example here. So here we declared an array called B, which is holding integers right from 1 to 10, and we displayed this particular array here. And next we iterated elements of the array and we multiplied each element by 4 here through the iterator $_, which is the default variable in PERL. And next, outside of the loop, we are displaying the elements of the array again. Now let us run this program. So before entering the loop, as expected, it is holding a value of right from 1 to 10, and after coming out of this for loop, so the values have been multiplied by 4 here. And also note that PERL supports C-style for loop. So the syntax for that is this. So for and within the parentheses, the initialization part and then the test expression and then the step. So inside this you can have your code block. So an example is here. Okay, so here again I define an array called C, which is holding integers from 1 to 10, and if you see now the for syntax is changed to a C style one. So here we are defining a variable called $I and initializing it with 0, and then we have our test expression, and $# as we discussed earlier, so is returns the highest index of the array, and then we are incrementing the I by 1, so and looping over. So this is returning the elements of this particular array. In this lesson we are going to look at while loop in PERL. So the while loop statement executes a code block repeatedly as long as the test condition remains true. The test condition is checked at the beginning of each iteration. Now let us see the syntax of while loop in PERL. So here if the condition evaluates to true, then the code which is inside this while loop gets executed. At the beginning of each iteration, the condition is re-evaluated. So and the loop is terminated if the condition evaluates to false. Okay, but do note that at some point in the loop we have to change some variables that make the condition become false. Otherwise, we will have an indefinite loop that makes our program execute until a stack overflow error occurs. Okay. And also we have this optional block called continue, which executes after each current iteration. But in practice, the continue block is rarely used. Okay, now let us go through a simple example to see how the while loop works in PERL. So in this example, I have declared a counter variable and setting this to a value of 5. And next, we put a condition to make sure that the value of counter is greater than 0 before entering the loop. Okay. And then inside this while loop, we displayed the $counter and decreased its value by 1 by using this $counter minus minus syntax. And we also used a sleep function here. So this is to pause the program for a second in each iteration. And after that, so we are using the if statement here. So to check if the $counter is 0 to print the this particular message. So the code block inside this loop executes 5 times before the counter is set to 0 again. And finally here, after each iteration, the $counter kept decreasing and its value was set to 0 after the 5th iteration. And that's when PERL terminated the loop here. Now let us run this program to see what we get. Okay, so after the end of the 5th iteration, this particular message is now printed on the screen. Okay. Okay, now let's take a look at while loop with diamond operator. So we often use the while loop statement with the diamond operator, which is this less than greater than symbol, to get the user's input from the command line. So this particular example is exactly that. So now let us see how this works here. First, we are assigning the user's input to the $input, okay, here, using the diamond operator. Because it doesn't specify any file handle for the diamond operator, PERL checks the special array called @ARGV, which is empty in this case. Here, that's why it instructs the diamond operator to read from stdin, which is from the keyboard. Okay, and next remove the new line character using the chomp here. So we have seen that in the previous lessons. Okay, and we are also converting the number that the user entered to an integer using this int function here. Now let us run this program and see. So now it expects a input from the user. Let me type a number here. Okay, now I am pressing Ctrl D to exit. Okay, so whatever the user inputs are entered, so they're being printed out here. Okay, so finally let's talk about the while loop statement modifier in PERL. So if you take a look at this example here, the while loop statement is placed right after the print statement. Okay, so PERL evaluates the statements from right to left. So it means that PERL evaluates the condition in the while statement at the beginning of each iteration. So we use the while loop statement modifier only when we have one statement to execute repeatedly based on a condition. So like in this example. So this particular program prints integers from 1 to 10 and then it terminates that. In this lesson we are going to learn about do while loop statement in PERL. In PERL, do while loop statement executes a code block repeatedly as long as a test condition is true. Both while and do while statements terminate the loop if the test condition is false. Unlike the while statement that checks the condition at the beginning of each iteration, the do while statement checks the condition at the end of each iteration. Here is the syntax for do while. Because do while loop statement checks the condition at the end of each iteration, the code block inside the loop always executes at least once. In addition, do is not a loop block. Therefore, we have to use some special techniques, which will be explained shortly, to use loop control flow statements such as next and last. Now let's take a look at this example here to see how do while works. So this is a typical example of a command line program that requests for user input until an exit command is provided. So here we are getting the input from the user using stdin function, and then we remove the new line character using charm function. And later we convert the user text into the lowercase using LC, and then we print the user input. And whenever the user input matches to by, then it terminates the loop. So let me key in some text here, some more text, and then if I press by, then it terminates the loop. Okay, so this is how do while works in Perl. Now let us go through do while with next and last statements. So as I just mentioned, to use next and last statements inside a do while loop, we have to use some special techniques. Okay, so I'll show you with some simple examples for that. First, let's take a look at do while with next statement. So in Perl, the next statement allows us to start the next iteration of the loop and skips the rest of the code below it. To use the next statement inside the do while loop, do note that we have to define an additional loop block for the next statement, so as shown here. Okay, and the same syntax can be rewritten as this way. So we can shorten the same syntax as shown here into this equivalent form. Both are essentially same. Yeah, both works the same way. Now let us look at this example to see how next statement works inside a do while loop. So basically here we have an array called A, which is having integers that contains both odd and even numbers, and we are trying to basically get the sum of all the odd integers. Okay, so that's the objective from this program here. So inside this do while loop, we remove the array element by using the shift function, and we start a new iteration if the element is an even number. Otherwise, we add it up to the sum odd variable. And this loop goes on as long as the value of scalar at A is greater than 0. So let me run this program. So yeah, this is what we get. So this is the sum of all odd integers in this array. Okay. Now let us see Perl do while with the last statement. Okay, so basically the last statement exits the do while loop immediately. It basically acts as the break statement in other languages such as C, C++. To use a do while statement with the last statement, again do note that we need to add another block to do the do while statement. So as shown here. So this loop label can be any user defined name. So some name followed by the colon, and within the parentheses you can have your do while with last. So mostly last is used with if conditions, and again this is mostly used inside loop structures such as while and for. Okay, now let me show you a simple example to understand how this last works inside do while loop statement. Okay, so here we define a variable and called A and initialized with 1. So before we enter into the do while, and then I have some label here, and inside this I have my do while statement. So inside that I'm incrementing A by 1 in each iteration, and whenever A reaches 10, then I'm saying you quit from this. Okay, so yeah. Now let me run this program and see what the output we get. Okay, so whenever $A reaches 10, then it comes out of the loop. So basically it terminates. In this lesson, we are going to look at until loop statement in PERL. So we have seen earlier that while loop statement, which executes a block of code repeatedly as long as a test condition is true. So if you replace the keyword while by the keyword until, the test is reversed, meaning it executes a block of code as long as the condition is false. In PERL, until statement is just the opposite to the while statement. Both until and while statements evaluate the condition at the beginning of each iteration. So here is the syntax for until. So until followed by expression, and then within the curly braces we can have our code block. And PERL provides an optional block for the until statement, which is the continue. So as shown here. So basically the continue block is executed after each current iteration. Okay, although this is rarely used in practice. Now let's take a look at a simple example to see how until works. So in this particular example, I am trying to initialize the dollar counter with a value of 10. And next, the until statement here checking if the dollar counter is equal to 0 before entering the loop. Because the result of the evaluation is false at the first iteration and it enters the loop. And then we are displaying the value of counter and then we are decrementing it by 1. And after that, when it goes to the second iteration, so the expression counter equal to 0 is evaluated again. And the loop continues as long as the result of the expression is false. And finally, after 10 iterations, so the dollar counter value becomes 0, which makes the condition become true. So that's when it terminates the loop. So if you see here, as expected, we are getting the values of 10 all the way down to 1. Okay, so this is the simple example to use the until. And let us see another example of until statement using an array here. So in this particular example, again, we have this variable called counter, which is initialized with 0. And now we have this array called numbers, which is having 5 elements as shown here. So in each iteration, we are using the shift function to remove the element of this particular array. And we are increasing the counter value by 1 using plus operator here. So finally, the loop is terminated whenever the @numbers array has no more elements. Let me run this program here. So as expected, it is printing out all the elements of this particular array. And when it comes out of this until loop, so it says it has removed 5 elements, which is the size of this array. Now let us see do until in PERL. So in PERL, do until loop statement allows us to execute a block of code repeatedly as long as a test condition is false. So here is the syntax for do until in PERL. So both do until and do while statements check the condition at the end of each iteration. Unlike the until or while statement, the do until statement executes the code block at least once regardless of the result of the condition. So let's take a look at this example here. So in this particular example, the code inside the do until loop gets executed. So it basically asks the user to input a command. So std in function is used for that. And then we are removing the new line character using charm function. And LC function to make the input command lowercase. And after that, we are displaying the user input on the screen. And next, when the user inputs a word quit, then the loop terminates because the condition now becomes true. Otherwise, the loop executes repeatedly, which asks the user to enter a command again. Let me execute this program here. So it expects a input from the user. Let me key in some text. So this print statement is confirming what I just entered. Let me key in something else. And now if I type quit, and that's when the loop terminates. Okay, so this is how do until works in Perl. So we can also use the next and last statements with do until, like we saw earlier with do while. But I'm not going to cover that here. References in Perl. A reference is a scalar variable that points to another object, which can be a scalar, an array, a hash, and so on. So a reference holds a memory address of the object that it points to. When a reference is dereferenced, you can manipulate data of the object that the reference refers to. And this act of retrieving data through a reference is called dereferencing. Alright, why do we need Perl references? Because a reference is a scalar variable, so you can put a reference inside arrays and hashes. You can create complex data structures such as arrays of arrays, arrays of hashes, and also hashes of hashes, and so on. Now let us look at the basic syntax of references in Perl. To create a reference to a variable or subroutine, so we use the unary backslash operator here in front of the variable or a subroutine. For example, in this case, to create a reference $abc that refers to scalar $xyz, we can do it like this. Okay. To dereference a reference, we will have to prefix dollar to a scalar, at to an array, percentage sign to a hash, and ampersand symbol to a subroutine. For example, here to dereference a scalar reference $abc, so we will have to use $$ and then abc. Okay. Now let's look into more details on the scalar references. So if you want to, here I have a scalar variable called $s, which is holding a value of integer 10. And if you want to create a reference that refers to this $s, so we'll have to write like this. So this is the reference, and this particular scalar variable now is prefixed with a backslash indicating the reference. Okay. So if you want to dereference the reference $sref, so you can put curly braces around the reference like this. And the same thing can also be written as in this form. So to make it even simpler. So in this case, we can omit the curly braces. Okay, so this is about the basic details of references. Now let us go through scalar, array, and hash references. First, we'll go through scalar references with an example here. So here we define a scalar variable $s and we initialize its value to 10. And then we are defining a reference called $sr, and this is pointed to the scalar $s. Okay, you can notice a backslash here. And next, we are dereferencing the reference $sr, and then we are multiplying its value with 2. The change has reflected the scalar $s as well. Okay. Now let us run this program. So the first print statement is printing 10, and then the next one as well, because it's a reference. And in the third print statement, so we see this scalar and then followed by some memory location, right? So here scalar means a scalar reference here. Let's say if you have an array or a hash reference, you will get array or hash in caps accordingly. A reference stores memory location of the object that it refers to. So as we discussed earlier. So this particular thing is the memory location of the scalar $s here. So you may get a different value depending on which system you are running on. Okay, now let's look at the array references in Perl. So here we have an array called A, which has the integer numbers from 1 to 10. And then we defined a reference that refers to the array $A. Okay, so you can notice a backslash here. This is used in front of the array variable, like the scalar variable we just saw. And in the for loop, we are dereferencing the reference, okay, $aref by using @$aref. So you can actually use curly braces if you want, for example, like this. Okay, but the earlier one was the shorter one. So yeah, so I just omit this curly braces to make it shorter. Okay, and then we are referring to each element of the array using this particular statement here. Now let me run this program and see what the output we get. So it is printing out all the elements of this array, right from 1 all the way up to 10. Okay. We can also apply array functions such as pop, push, shift, unshift, sort, and so on to the array reference as usual. Okay, now let's move on to hash references in PERL. So we'll take a look at this example to understand that. So here we created a hash called week, and then we are dereferencing the hash by using this syntax again. So you can notice a backslash in front of the hash name. Okay, because a hash element is a scalar, to access hash elements through the reference, we use the operator hyphen and then followed by this greater than symbol. Okay, so here basically this particular program prints all the elements of this particular hash. So the reference is week or here. Okay, so as you can see here, it is printing out all the keys and values of this particular hash. Okay, so this is a simple example of hash reference in PERL. Subroutines in PERL. A subroutine is a block of code that can be reusable across programs. A PERL subroutine is very flexible and powerful. So we can actually define a subroutine anywhere in our programs. If you have subroutines defined in another file, you can load them up in your program by using the use, do, or require statement. A PERL subroutine can be generated at runtime by using the eval function as shown here. So you can call a subroutine directly or indirectly via a reference, a variable, or an object. Okay, now let's take a look at the basic syntax of subroutine. So sub indicates the subroutine, which is the keyword, and then followed by the subroutine name, and then we have prototypes that tells PERL what parameters the subroutine expects, and then we have attributes that gives subroutine additional semantics. So PERL provides 3 standard attributes that include locked, method, and value. Both prototypes and attributes are optional. And finally, we have block. That's where we'll have our code. Okay, now let's write a simple subroutine. So here I'm writing a simple program for the subroutine. The name of the subroutine is subroutine underscore name. And then inside the parentheses, I have some print statement. And to call this subroutine, I'm using this syntax here, subroutine name and then followed by the empty parentheses. So now if you run this program, you get this statement from the print. Okay, so you can call subroutine in 2 ways. So one of them is as shown here, using the subroutine name and then followed by the empty parentheses. And you can also call this subroutine by using the ampersand as a prefix before the subroutine name. Okay, both are same, so both works fine. But do note that in some cases, ampersand is must. So for example, here you are using a reference. So you notice a backslash here. Okay, so this refers to the subroutine name. So in this case, you should use ampersand sign before the your subroutine name. And also in these two cases, you should use ampersand sign as a prefix as well. So in this case, you are calling indirectly. So like when you use the subroutine name as an argument of defined or undef function, for example. Okay, so this is how you call this subroutine. Now let's take a look at subroutine parameters using this simple example. So it is more useful if we can pass parameters to a subroutine as the inputs and get something out of it. In Perl, all input parameters of a subroutine are stored in a special array, which is the @_. So if you want to refer the nth argument, just use the $_n-1. So in this example, we define the subroutine called sum that calculates the sum of its arguments. And we looped over the elements of the @_ array, and then we added up their values. And finally, we are returning the result by using the return statement. Okay. So here the @_ array is used as an alias of the arguments. Therefore, whenever you make any changes to the elements of this particular array, the corresponding argument changes as well. Okay. And also note that when you pass an array or a hash to a subroutine, you actually pass all elements of the array or hash to it. But to pass an array or a hash to a subroutine, you must pass a reference that refers to the array or hash. So we'll see that a little later. Now let me run this program. So this is now returning the value of $total, which is the sum of all the elements of this particular array. Okay. Now let us look at the returning values of a subroutine. So this can be done in two ways. So a subroutine returns the value implicitly and explicitly. So now let's take a look at the implicit returning value. So a subroutine implicitly returns a value that is the result of the last expression in its body. Okay. In this particular example, $name is the value that we get from this subroutine. So when you call this particular subroutine, the last statement, which is the value of $name, is the output that we get. This is the implicit way of returning something from the subroutine. And we can also explicitly specify the return statement to return something from this subroutine. So this will also return the same output as earlier. But in this case, we are explicitly specifying return statement. Okay, so that's about the returning values from a subroutine. So there is one note here about the return statement. So inside a subroutine, whenever the return statement is reached, the rest of the subroutine is skipped and a value is returned. Okay, now let me show you an example to return an undef value in Perl. So sometimes it is useful to return an undefined value undef from a subroutine so that we can distinguish between a failed call from the one that returns false or no results. Okay. For example, a subroutine may return an undefined value undef when a particular parameter is not supplied. So this example is showing that. So here we define a subroutine min, and then that returns the minimum element of an array. Okay. And if the array is empty, the subroutine returns the undef value. So in the main program, we pass the @array to the subroutine. Okay. Because at A is an empty, if you notice here, at A is an empty array. So the returning value that is assigned to this particular $j is undefined, which is undef. And then we used define function to check the variable is defined or not. So in this case, it returns false. So, and it should display this message, the array A is empty. And finally, we are passing an array at B, which is having these elements, okay, to the subroutine min. Okay, so in this case, we expect the minimum value out of this all elements from this particular subroutine. So this is the logic to do that. Now let us see what it returns here. So first it says the array A is empty, so as expected, because this is where returning the undef is so important. And then this particular subroutine is doing the logic of getting the minimum element out of this array, which is the B array. So the minimum value is 2 from these integer values here. Now let us see how to pass array references to a subroutine, and also we will see how to define the subroutine that returns an array. First, take a look at passing an array to a subroutine using this example here. Okay, so here we are defining an array called A, which is having these integers. And next, we are passing a reference to the array using \at A to the subroutine max. And inside this subroutine, we are defining a lexical variable, which is the aref, and setting its elements values to the array reference stored in the argument array, which is the default one at _. And we are assigning the first element of the array to a variable called I. And we are going to use this as a reference to compare with the next element. So inside this for loop, we are iterating over array elements via this lexical reference to find the maximum element. And finally, we are returning the maximum value as a scalar from this subroutine. So if you run this program here, we get the maximum value out of these elements. Okay, so this is how we pass an array to a subroutine. And now let us see how to return an array from this subroutine. So by applying the same technique, we can also pass multiple arrays to a subroutine. So in the previous example, we passed only one array. So in this case, we are going to pass multiple arrays. So basically a couple of arrays here. And then we are returning an array from this subroutine. So, okay, so this particular program is going to remove the elements, removing the last element of the array from both A and B here. So this is how it works here. So inside the subroutine pops up, we are declaring an empty array to store the elements that we are going to remove from these two input arrays. And then next we are looping over at _array to get the corresponding array argument. And then we are using the pop function to remove the last element of the array. And then we are pushing it to the lexical array, which is this array here. And then we are returning the lexical array from this subroutine. Okay, so which should return the elements that we removed using the pop. So basically 5 and 1. Okay, so that's what this program is outputting. So the elements that we have removed using the pop function. Okay, so this is how we can return an array from a subroutine. Regular expressions in PERL. PERL regular expression is the most powerful feature of the PERL programming language. So a regular expression can be either simple or complex. depending on the pattern that you want to match. So here is the basic syntax of regular expression matching. The operator equals followed by tilde is called the binding operator, and the whole expression here returns a value to indicate whether the regular expression is able to match the string successfully. Let's take a look at basic simple word matching first. So the simple regular expression is simply a word, more generally a string of characters. So a regex consisting of a word matches any string that contains that word. So in this statement here, the uppercase PERL is a regular expression. And the delimiters forward slashes here enclosing this pattern tells PERL to search a string for a match. And the binding operator associates the string with the regex match and produces a true value if the regex matched, or false if the regex didn't match. So in this example here, the uppercase PERL matches with the second word in this string. So the expression is true. So let us take a look at this example here. So expressions like this are quite useful in conditionals. So in this example, we are using a if condition and we are checking something using the regular expression. So we are trying to find if this particular pattern exists in our string. Since uppercase PERL is matching with the second word in this string, so it prints this. And the sense of the match can be reversed by using the exclamation and then followed by tilde. So look at this example here. So what we are trying to do is we are trying to find the elements which do not contain this substring at, and we are printing those elements. So as you can see here, these elements do not contain the substring at. So this is how you can use the negated form of binding operator. Okay, and the literal string in the regex can be replaced by a variable also. For example, you can have your pattern assigned to a variable. So in this case, it is assigned to $sub, and then I'm trying to use the $sub in my regular expression to match my string. Okay, and if you are matching against $_, which is the default variable in PERL, so you don't have to use the binding operator. So for example, you can discard this thing. So basically, you can omit this statement here. So you can straight away write your regular expression within the delimiters. Okay. And finally, the delimiters that we have been seeing so far are forward slashes. So they can be changed to any arbitrary delimiters by putting an M out front as shown here. So the delimiter here used is double quotes. Let us take a look at another example with another delimiter here. So we have some elements in this array and we are trying to find if the element contains the forward slash. So as you notice here, the delimiter used is double quote, but let me change this to colon. So it should still work. So as expected, the elements which contain the forward slash in it, so they are matching. Okay, now let us look at the case sensitivity with regular expressions. So by default, it is case sensitive. So meaning it will only match the specific case, lower or upper case. So in this particular example, this expression is false. So that's because our string does not contain an uppercase P and then lowercase URLs. So if you want to make this case insensitive, you will have to use the modifier after your regular expression. The modifier is I, as shown here. So after your regular expression, you will have to use the modifier I. So this will make the regular expression matching case insensitive. Okay, now let's take a look at regular expressions with quantifiers. So far in the previous examples, we have created regular expressions by simply putting the characters we want to match between a pair of delimiters. What if you want to find the same sequence of characters multiple times? So you may quickly something like this. So if you have small a which is repeating 2 times, so you can quickly write something like this. But how about 20 times or even more? So fortunately, regular expression engine provides us with quantifiers to build such kind of patterns. So for example, if you want to match a 20 times in this particular text, so you can use this quantifier. So lowercase a followed by the number of occurrences within the curly braces. Okay. Okay, now let's look at the matching repetitions. So inside PERL, so we have various quantifiers. So the quantifier meta character star plus curly braces or question mark allow us to determine the number of repeats of a portion of a regex we consider to be a match. Quantifiers are basically put immediately after the character or character class or grouping that you want to specify. So let's take a look at these quantifiers here. So they have the specific meaning. So A star matches A 0 or 1 time. If it is plus, then it matches 1 or more times, and star matches 0 or more times. And if you have the number of occurrences within the curly braces, that matches exactly that many number of times. And if you have n comma, then it matches at least n or more times. And you can have your range defined like this, n comma m. So this matches at least n times, but not more than m times. Okay. So take a look at this example here. So we have some elements in this array, and we are trying to see if a name has a uppercase A, so it can be 0 or more times, and then lowercase s 1 or more times. So if it matches this regular expression, then we are printing that particular element. So as you can see here, these two elements are matching with this expression. However, the second element does not contain this lowercase s, so it didn't match. Okay, so that's about the quantifiers. And do note that not all characters can be used as is in a match. Some characters, they are called meta characters, are considered special, and they are reserved for use in regex notation. So as shown here, the meta characters are curly braces, square brackets, parentheses, and all this as shown here. So let me show you a simple example for this. Let's say I have this string which has the star sign in it, and I'm trying to match it literally first. Let us see what happens. So it flags an error. So for this, you will have to escape with the backslash if you want to match the star sign. So then it matches. So basically a meta character can be matched literally by putting a backslash before it. And this is applied for all these meta characters as well. Okay. So let us look at the variable substitution now. So regex are treated mostly as double quoted strings. So variable substitution works here. So as I mentioned earlier, we can have our pattern assigned into a variable, and then we can use that variable value inside the regular expression. Okay, like this. This is about the variable substitution in the regular expression. And finally, let's take a look at the usage of anchor meta characters, which are caret and the dollar sign. So with all the regular expressions we have seen above, or like we can match the regex anywhere in the string. So it was considered a match. To specify where it should match, we should use the anchor meta characters, which are caret and the dollar sign. So caret means matches at the beginning of the string, and the anchor dollar sign match at the end of the string or before a new line at the end of the string. Let's take a look at this example here. So I have a string called ABC and which has this value, and I'm trying to check my string with various regular expressions here. So as you can see here, since my string has blue in it, so it matches, and it is also starting with blue, so it matches, and the string is ending with berry, so this one is also evaluates to true, so this prints the statement. And finally, we are matching the exact word. So if you have your pattern enclosed in the enclosed between the caret and dollar sign, that means you are matching the exact string. So the end character over here shown, so it will still work even if you have a new line character at the end of your string. Okay. And let me just change this slightly. I'm trying to introduce a space into my string at the beginning. So now over here, only the first one and the third one matches. Second one and the fourth one fails. That's because this string now is not the exact match to this string because it has a space. And also it is not starting with blue, so it is starting with a space. So this also fails. So far we have built regular expressions with literal strings. For example, to match cat in this array elements, we can write the literal string inside the delimiters and we can match that way. However, regular expression engine allows us to build regular expressions that represent not just only a single character sequence, but also a whole class of them. For example, digits, white space, and words, stuff like that. Okay, so we use square brackets to denote the character classes inside the regular expression. Inside the square brackets, we can put set of characters that you want to match. So for example, if you want to match words which are ending with AT and let's say beginning with C, H, R, so you can have them in the square brackets. So that way you can match 3 elements. Okay. Take a look at this example here. So even though C is the first character in the class, the earliest point at which the regex can match is character A. It's not C in this case. So another example here. So to match this string here, so you can have your character class as shown here. So for each character, you can write lowercase and uppercase in the character class to match that. Or as discussed earlier, so you can use the modifier which is I after the regular expression to match that. So okay, this way you can make the matching case insensitive. Okay, character classes also have ordinary and special characters, but the sets of ordinary and special characters inside a character class are different than those outside a character class. The special characters for a character class are as shown here: hyphen, closing square bracket, backslash, caret, and then dollar. So these are special characters, and if you want to match them literally, so you'll have to escape them with a backslash. Okay, so let's look at some of the examples to understand that. Let's say if I want to match this particular element here. So if I write my expression like this, so this will not work out because Perl will flag an error on this, because you're trying to use a special character dollar inside the character class. So as I just mentioned, you will have to escape with a backslash, so to match the literal dollar. Okay. And if you look at this, so here I have a variable called x, which is having these three characters. And let me use this variable value inside my character class. Okay, so this time I'm changing this string to 80. So this will match these three elements. Okay, that's because here $x is interpolated. So basically it has been replaced with its value. Okay, so this is the use of using a variable value inside the character class. And let's say if you want to backslash this, so now it will only match literal dollar and then followed by this string, and also this x and then followed by this string. So in this case, dollar is a literal dollar here, so it's not $x. And let's put one more backslash here. So now what happens is backslash is a literal character, and since there is no backslash for dollar, so now it is treated as a $x. So $x will be replaced with its value. So now you will have $x value here and then one literal backslash. So okay, because $x has been replaced with its characters bhr, so that will match these three, and then we have a backslash, literal backslash, so that will match the literal backslash and then followed by this string. Okay. If hyphen is the first or last character in the character class, it is treated as an ordinary character. However, the special character hyphen acts as a range operator within the character class. So let me show you an example. So if I want to match any string that is starting with item and then followed by some number, so let's say I want to match items 0 to 100. So out of these array elements, so I can write my range operator inside the character class like this. Okay. So as I just mentioned, if hyphen is the first or the last character in a character class, it is treated as an ordinary character. However, if you use it as a range, so this has a special meaning. And the special character caret in the first position of a character class denotes a negated character class, which matches any character but those in the brackets. So let me show you an example. Let's say if I have caret a and then followed by 80, so this will match any character apart from a and followed by this substring 80. Okay, so those elements will be matched except the one starting with a. Okay, so this is the negated form of character class using the caret symbol. And let's say if I replace a with something like 0 to 9, so this will match the characters which are not starting with a digit 0 to 9. Okay. Now let me change the order for caret symbol. Now I want to put this at the end. So now it is treated as a normal character. So now we have two characters inside the character class, which is A and then the literal caret symbol. So that will match these two combinations. Okay, so that's about using special characters inside the character classes. Now let's take a look at common abbreviations for common character classes. So we have several of those. So this is the list of different abbreviations for common character classes. So /D matches any digits starting from 0 to 9, and \s matches whitespace characters, so as shown here, and \w matches alphanumeric or underscore. And if you have the uppercase for these three combinations, they do the other way. So \D matches non-digits, and uppercase S matches non-whitespace characters, and \uppercase W matches non-word characters, and finally dot matches any character except a new line character. Okay, take a look at some of the examples to understand this. Okay, so to match this particular element here, we can write something like this, colon, and then, so in this case, \D matches only one digit, so I put plus to match one or more characters, and then I'm matching the literal colon, and I'm repeating this 3 times. So this will match this particular element from this array. Okay, and let's say if you want to match any digit or whitespace character, so you can write something like \D and then \S. This will match a digit or a space character. Okay, so as you can see here, elements which are having digits and having space are getting matched. And let's say if you want to match a word character followed by a non-word character and then followed by a word character again, so you can write \lowercase w and uppercase W and then lowercase w. Okay, so this will match the word character followed by non-word and followed by a word character. Okay, so these are the elements that meet this criteria. And let's say if you want to match a literal character, any character except the new line, so you can use the dot as I just mentioned above. Let's say I want to match any 2 characters and ending with let's say 80 here. So this will match this particular element here. Okay. So dot is to match any character except the new line character. And let us write one more pattern here. Let's say I want to match a word end and then followed by a literal dot. So to match the literal dot, you will have to \. it. So that way you match the literal dot. And you can have that inside the character class within the square brackets. Okay, so to match the same string also. Okay, now let's talk about the word anchor. So word anchor \b, lowercase b, matches a boundary between a word character and a non-word character. For example, \lowercase w and then \uppercase w, or vice versa. So here I have this expression. So as you notice, we have backslash lowercase p and then followed by this element here. So this will match basically the elements which are starting with this particular string. Okay, let's say if I put this at the end, then this will match the words which are ending with this particular string. Okay, and let's say if I put backslash b both at the beginning and the ending, so this will match exactly that word. So this is how you define the boundaries for a word. In some cases, you want to build a regular expression that matches different possible words, this or that. So in order to do so, you need to use the alternation meta character, which is the pipe symbol as shown here. So this way we can match different character strings. PERL will try to match the regex at the earliest possible point in the string. At each character position, PERL will try to match the first alternative. If this one doesn't match, then you try the next alternative. Okay, and if this one doesn't match either, then the match fails and then it moves to the next position in the string. Take a look at this example here. So we are trying to find elements which are matching to this string or this string. So from this array, so we have two matches. Okay, so this is a simple use of using the alternation meta character. Let us see some more examples to see about the grouping and hierarchical matching stuff in PERL. So the grouping meta characters, which are the parentheses, allow a part of regex to be treated as a single unit. Parts of a regex are grouped by enclosing them in the parentheses. For example, if I want to match elements which have a character of A or B and then ending with a character of X, I can write my expression like this. So this matches three elements. And let's say if I want to match a string which is starting with a character A and then also containing a character B and then finally ending with X, so I can modify my expression like this. And this matches only two now. Because the third one didn't match, that's because this is not starting with character A now. Okay. Let me show you another example. So let's say I want to match strings which is starting with this string and then also having this particular thing. So if I write my expression like this, so this matches two things. Okay. And let's say sometimes you may want to just match the first string. So in case even if the second match in the parentheses didn't match. So in that case, you can use the null alternative. So to do that, you just have to put your alternation meta character followed by a null character basically. So this way you can match the first string as well. And you can also have nested groupings like as shown here. Okay, so this one matches only two now because we didn't have the null alternative. Let's say if you have an null alternative here, so this one still match the three matches as shown in the above example. Okay, so this is about the nested groupings in PERL. Now let us see how to extract matches in PERL. The grouping meta characters which we have seen just now, the parentheses, also allow the extraction of the parts of a string that matched. Okay, so for each grouping, the part that matched inside goes into a special variable called $1, $2, and so on. So they can be used just as ordinary variables. For example, over here, $1 returns a value of 10. That's because the first matching in this group is 10, because if you see the expression here, \d matches any single digit and followed by plus means one or more characters of those. So that means 10 here, because after that we have this literal semicolon getting matched, and we are repeating this 2 more times. So if you print $2 and $3, you will get 20 and 30. So yeah, $1 returns 10, $2 20, and then $3 30. So this way you can save your matches into these variables. Let us see some more examples. Okay, so here we have some of the elements as shown here in this array. Let's try to use the repetitions and in combinations with quantifier meta characters we have seen earlier. Okay, let's say if you want to match an element which is having a lowercase word and then after that a space probably. So we can write expression as shown here. So I'm trying to match a lowercase word and a space after that. So we got 2 matches. And let me show you another example using the back references. So here I'm trying to group my first word inside the parenthesis, and then I'm trying to match a space, okay, 1 space or more spaces, and then followed by \G1, which is the back reference. Okay, so this one will match the first. Okay, basically \G1 is the first match that is grouped as shown here. Let's say if we have one more match which is grouped, so to access that you will have to use \G2. Just like we saw just now with $1 and $2, so we can use the back references this way. So this is quite useful if you want to find repetitive words in your string. Okay. So the difference between using $1 and \G1 is, so basically $1, $2 and so on, they should be only used outside of a regular expression. Okay. However, \G1 and \G2, these are called the back references, and they can only be used inside a regular expression. So if you notice here, we have this inside our regular expression, not outside. Okay, so that's the basic difference between $1 and \G1. Let us try to write some more expressions. Let's say I want to match a number which is having 2 digits or 3 digits or 4 digits. So I can define my range in the curly braces 2 to 4, and I'm trying to match exactly the number. So I define my boundaries using these anchor meta characters, caret and $. Sorry, I missed a \/ here. Okay, so this will match numbers which is having a length of 2 to 4. Okay, so let's say if I want to match numbers which is having a length of 2 or only 4. So I want to throw out numbers which are having 3 digits, for example. So I can change my expression by using the alternation meta character again here. So now I'm trying to match numbers which are having a length of 2 or 4. I don't want to match numbers which are having a length of 3, basically 3 digits. So I'm just discarding them using this expression. Okay, so these are some of the examples showing how to use the matching repetitions along with the combination of quantifiers and also the use of alternation meta character. Let us see one more example to see how a greedy quantifier works in Perl. Okay, so the quantifiers we have seen just now will try to match as much of the string as possible while still allowing the regex to match. For example, here we have this string and we are trying to group certain patterns. Okay, so we have 3 groupings here, And let's say if I print my $1 here, so this returns a match which is stored in this first grouping. So basically the star is a greedy quantifier, so this will match until here, because after that we are matching the literal 80. So before that, so it matches everything. Okay, and if you print $2, it will be only at. Okay, and if you print $3, you don't see anything here because all the string is already matched until this point. Okay, that's why we call this as a greedy quantifier. So it matches until this particular thing, because after that you are matching this particular substring, so at least it stopped here. Let's say if you want to stop the matching at the first occurrence, because here we have at, right? So if you want to, if your intention is to match only until here, then you'll have to modify this slightly. So you'll have to add a question mark here. And now if you try to print $1, this should return only the space and R. Okay. And now if you print your $2, then this will be at again. And now if you print $3, so you have the string after this 80 string, which is this one, highlighted one. Okay, so this is how you make the greedy quantifiers modified into non-greedy ones using this question mark. Okay, now let us see some more matchings using some of the examples here. So I have this variable called x, which are having these elements. So, okay, there are a few more things basically you might want to know about the matching operators. So the global modifier is one of them, /g, which allows the matching operator to match within a string as many times as possible. Okay, in scalar context, successive matches against a string will have \g jump from match to match. So keeping track of position in the string as it goes along. And here we are trying to use the function POS to get the position. So let me execute this program and show you what's the output we get. So here we are getting the positions of all the elements in this array. Okay, because the $1 returns the word character, which basically matches all the elements in this particular thing. Okay, a failed match or changing the target string resets the position. Okay, if you don't want the position reset after failure to match, you can add the modifier \c instead of g here. So if you want to match globally and then if you want to reset, then you will have to use \gc. Okay, in list context, \g returns a list of matched groupings, or if there are no groupings, a list of matches to the whole regex. For example, if you see this thing here, so here if you print $0, it returns the first element. And $1 returns the second element. Now let's take a look at search and replace. So the syntax for search and replace is done using this syntax. So as you can see here, S and then followed by the delimiter and then our regular expression and then the delimiter and then the replacement string. So this is a PERL double quoted string that replaces in the string whatever is matched with the regex. And then finally we have some modifiers that we can apply on this expression. So we'll see that with some examples. So a simple example is here. So we have this value assigned into a variable x, and we are trying to replace the substring blue with rasp here. Okay, so this way we can find something and we can replace in that. Let us take a look at another example here. So we are using grouping here. So using grouping, what I'm doing is I'm trying to get the value which is enclosed in this single quotes. Okay, and I'm using that matched value to replace this. Okay, so now we get the output of only the string which is enclosed in the single quotes. So if you notice here, we have used a $1 here. Okay, so using the search and replace operator in Perl, the matched variables $1, $2, and so on, they are immediately available for use in the replacement expression. Okay. Another example here. So here I'm trying to replace a number 5 with a string 5. But do note that this will only replace the first occurrence. Okay. But if you want to replace all the occurrences, you will have to use the modifier G here. So if you use G, then it search and replace all the occurrences in that particular string. We have one more example here. So here I am trying to show you the use of modifier I as well. So using I, you can make the matching case insensitive. So that way you can replace all the letters irrespective of lowercase or uppercase, and I'm trying to replace that particular thing with this substring here. Okay, and I'm doing that globally. So it replaces on all the occurrences. Now let us take a look at the another modifier, which is the non-destructive modifier, which is R. This causes the result of the substitution to be returned instead of modifying the $_ or whatever the variable the substitute was bound to with the binding operator. So this way we can have our expression with the substituted value. Let's say if you didn't have this flag R, then as you can see here, we get the first string, and then after that the return value of this particular expression is printed, which is 1. Okay, so that's the use of non-destructive modifier R. We have one more example for the same. So we can have multiple statements in a single line, so as shown here. We have one more example with arrays here. So here we are trying to replace all the lowercase letters with a uppercase X. Okay, so as you see here, the lowercase letters are replaced with uppercase X, but not the numbers. Now let us take a look at another modifier in Perl, which is E, which is the evaluation modifier. So basically this one wraps an eval function around the replacement string, and the evaluated result is submitted for the matched substring. So here we are using the reverse function to reverse the string. So as you see here, we are reversing each word. So that word is now grouped in the parentheses. So we can access that using the $1. Let us say if you didn't have this modifier, evaluation modifier E, then you will get the literal value of reverse and then followed by each element in this particular variable. Okay, so that's the difference between using E. And we have one more example here. So here I am trying to replace this value with its equivalent decimal number. Okay, so basically I am trying to match the number from this string using this \d plus, and then I am grouping that match into this $1, so that I can access that value using the $1, and in the replacement string I am dividing it by 100. And as you notice here, we are using the evaluation modifier. Okay. And if you notice here, we are using a different delimiter. So here I use colon. So you can use any non-alphanumeric character for delimiter, as we have seen earlier. So if single quotes are used in this expression, then the regex and the replacements are treated as single quoted strings. Okay, that's all we have for search and replace. In this lesson, we are going to learn about file operations in PERL. So to open a file, we use this syntax open and then followed by these three parameters. A file handle is a variable that associates with a file. Through this variable, we can read from the file or write to the file depending on how we open it. And mode is basically read, write or append. File name is the path to the file that is being opened. To open a file in a specific mode, we need to pass the corresponding operand to the open function. For example, to open a file in read mode, we use less than sign. So in this mode, we can only read the file, but we cannot change the content. And if you want to open the file in write mode, we use the greater than sign. So in this mode, if the file doesn't exist, a new one is created. If the file already exists, the content of the file is wiped out. So we should use this write mode with extra caution. And finally, the append mode is done with the two greater than signs. In this mode, we can open file for appending new content to the existing content of the file. However, we cannot change the existing content in the file. That's about file modes. Let's say if you want to open a file called test.txt in read mode, this is the syntax. So here the open file returns true on success and false on failure. We can use die function to handle a file opening failure. So for example, you may want to know the existence of this file before you open it. Okay. So in that case, this is quite useful. So it flags an error if this file doesn't exist. So here the special variable dollar followed by exclamation conveys the error message telling why the open function failed. And finally, to close the file, we use close function followed by the file handle variable name. Now let us open a file in read mode. So as shown here, I am trying to open a file called test.txt. Okay, and I am printing this if it is successful. So before I run this program, let me list down my current directory where I am running this program. Okay, since my current directory does not have this file yet, so when you run this program, we should expect PERL to flag an error. Okay, so here it complains saying that no such file or directory. So let me just create that file and rerun the program again. So now it opens successfully. Okay, so this is the simple use of how to open a file. Now let us see how to read a file in Perl. So this is the syntax. So basically to read file in scalar context. So in order to read the file in read mode, we put the file handle variable inside the angular brackets as shown here. And to read the next line of the file with new line included, we use this syntax. So here we have $line getting assigned with this thing which we just discussed. Okay. Now let's try to read a file and print its content onto the screen. Okay, so here I'm trying to read the file called test.txt and using this syntax which we discussed just now. So I'm looping through this file and I'm trying to print each line using this internal variable $_. So before I run this, let me just see what test.txt has got. Because it's an empty file now, let me put in something into it. And save this file and let me run this program now. So it prints the content of this file which we just created. Okay. So this is how we read from the file and we can output onto the screen. Let's say in this case, I have my file name explicitly hard-coded into this variable, right? So let's say if I want to pass my file as a command line argument, for example. So I can use this diamond shaped operator. So as you notice here, within the less than greater than symbol, we don't have the file handle variable here. That's because I'm going to pass my file as a command line argument. Okay, so this returns the same output as the previous one. So this is how we can pass the file name as a command line argument. So here basically the diamond operator checks if the program was invoked with a command line argument. So in this case it did. So it reads from the file in scalar context, one line at a time. Let's say if you have provided multiple files at the command line arguments. Okay, so it will read the content of all files in sequence in list context. Okay, so that's about the reading a file. Now let's move on to writing into a file with some example. So this is the syntax. So here we are using the print function to write data into a file which is opened with the file handle fh, and $s variable here holds data that is written to the file. So do note that if you write to a file that contains content, Perl will truncate its content. Okay, so this is how we open a file in write mode using the greater than symbol, and then we put some content into that, and then finally we close that file. So it's always better to close the file explicitly when you no longer need it. Okay, so let's try to put something into a file. So here I have my variable called $s. Into that, so I'm inserting this text using this syntax here. And now I'm opening a file called test.2 in write mode using the greater than sign as shown here. And then I'm putting the value of $s into this file using this syntax which we discussed just now. And once that is done, I'm closing the file. And finally, I'm printing the status if it is put successfully or not. Okay, so it says writing to file successfully. So let me just see what my text.txt has now. So as expected, the text that we have in $s is now being reflected into this file. Okay, so that's the simple example on how to write into a file. Now let us see another example where we can copy a file content into another one. So here I have two files, test2 and test3. So I'm opening test2 in read mode and test3 in write mode. So I'm going to read the data from test2.txt and then I'm putting that file content into this file called test3.txt using the syntax which we just saw it. Okay, so I'm looping through the source file, which is the test2.txt using this syntax, and I'm putting the content of that using the special variable $_ into this file called test3.txt. Okay, it says file content copied successfully. Now if I do diff, we should not see any difference. So in this example, I have explicitly mentioned my file names into these variables, right? So let's say if I want to pass these file names from the command line. So I will have to use a slightly different syntax for that. Okay, so when the program is invoked, the command line arguments are stored into a special array which is called the uppercase argv, and we are using the shift function here to get the source and destination files from this array. So as I just said, I'm going to pass my file names through the command line now. Okay, so it says file content copied successfully. Again, if you do the diff, it should be the same. So we shouldn't see any difference here. Okay, so that's how we copy the content from one file to another. And finally, let's look at the file operators in PERL. So before reading from a file or writing to a file, it is important to check if the file exists and readable. So in order to perform those tasks, we use PERL file test operators. The PERL file test operators are logical operators which return true or false value. Okay. For example, to check if a file exists, so we can use -e operator as shown here. Okay, so we have quite a number of operators that are supported in PERL. So some of the important operators are shown here. Okay, so we can go through them using the PERL manuals. So let me show you a simple example how to use multiple file test operators. For example, if you want to check if your file is a plain file, not a directory, and if the file exists and if the file is readable. So you can use this syntax as shown here. So we can use a logical AND operator. So that's what is used here. So you can use any other logical operators depending on your requirements. So whenever we use the file test operator, PERL will make a new call of stat. Okay. However, PERL stores the result from the last stat call to a special file handle, which is this underscore. So the subsequent file test operators can use the result that stores in this file handle. So the same expression can be written in another way as shown here. So you can combine these three operators separated with a space as shown here. Now let's learn modules in PERL, which is the last topic in this tutorial. A module in PERL is a collection of related subroutines and variables that perform a set of programming tasks. Basically, PERL modules are reusable. So we have various PERL modules available on the comprehensive PERL archive network, which is also known as CPAN. So these modules cover a wide range of categories such as network, XML processing, CGI, database interfacing, and so on. Okay, let's create a PERL module. So before we create it, just take note, a module name must be same as to the name of the package, and it should end with .pm extension. So in this particular example, I'm going to create a calculator module. As you can see, it is ending with the .pm extension. So inside this, we have package and then followed by the name, which is calc here. And okay, so inside this, we have two subroutines to perform addition and multiplication of two inputs. Okay, and this particular file is ending with a value of 1. So this is basically to return a true value to the PERL interpreter. So PERL accepts anything which is true instead of 1. But do note, the newer versions of PERL don't need this statement. We are putting it here just for the backward compatibility. And now let us see how we can import this module into the main script. Okay, so to import the package, okay, calc that we just created, we can use require or use functions. So over here I'm using use. Okay, to access the function, okay, from a module which we have just created, we should use the double colon operator. So this is the module we just created, and I'm going to perform addition on two user inputs here. So okay, so I can call it this way, and for the multiplication I call it this way. So it expects input from the user. Let me key in two numbers. Okay, so here we have the addition result, and next we are performing the multiplication operation. Let me key in another two numbers. Okay, so this outputs the result of the multiplication of these two inputs. Okay, so that's how we work with modules in PERL. Now let us see another example for using variables from modules. Okay, so basically variables from different packages can be used by declaring them before using. So let's take a look at this example. So inside my message module, I have this variable. Since I am going to access this outside this program, so I am defining it with our scope, okay, which makes it global. So as we have discussed earlier in this tutorial. And finally, it is ending with 1 as we just discussed. And if you look at this script here, so I'm going to use this uname, okay, so which is defined in the module which I just showed you, okay, and I'm going to pass this value and I'm trying to print that particular thing using this subroutine call. So here you go. So we are able to access the variable which is defined in the module. That concludes the tutorial. Although PERL has many more features like object-oriented programming, database-independent modules to interact with various databases, stuff like that, as I mentioned in the beginning, the intention of this tutorial is to cover only the basics. Thanks for watching the video. I hope you found it useful. If you did, please help to like and subscribe for more videos. See you next time.